Hey everybody, this is 11.2. The first one says, what's the inflection point? So we learned in the last video to find the inflection point, we have to find the first and second derivative. So let's find our first derivative. We take this fraction and bring it down and multiply it with that 4. And so you can put that in the calculator if you want. You can say 4 parentheses 5 divided by 3. Then press math, enter, and I got 20 over 3. X to the, don't forget to subtract 1 from the air, but that does not make 4 over 3. I'll put it in my calculator. Let me put parentheses 5 divided by 3, close parentheses minus 1. And then math, enter. Oh, it makes 2 over 3. And then the derivative of the 7 just cancels out. Okay, now if I take the second derivative, I take this exponent, 2 over 3, and sorry, that was my email, and I bring it down and multiply it with this number in front. So 2 divided by 3 times 20 divided by 3. Math, enter. I got 40 over 9. X to the whatever 2 over 3 minus 1 is. So let me find 2 divided by 3. 2 divided by 3 minus 1 equals negative 1 over 3. Okay, so we found our first and second derivative. Okay, then if we look at our tricks for 11.2, it says how to find inflection point. Complete the steps for concavity. Oh no, let's go back to concavity. For concavity, we have to find the first derivative, did it. Second derivative, did it. Second derivative equals to 0. Let's do it. So 40 over 9, x to the negative 1 over 3 equals 0. Okay, then it says we need to equal it to 0. We did it. Now we need to solve for x. So if we look at this little underneath solve for x, it says if you just have a number x to another number and it's equal to 0, then StatMap will always give you x equals 0. This is a shortcut. So let's see, do I have a number x and a number in the air? Then equals 0. Number x, number in the air equals 0. Oh, I do. Hey, okay. So that says no matter what, StatMap will always give you x equals 0. So because I have a number x to another number, it's always going to spit out a 0. If I really wanted to do this like the right way, I would have to take 40 over 9 and take that x to the negative 1/3 and put it in a house on the bottom. Then we'd have to like multiply, cross multiply and divide and a bunch of other stuff. And we don't want to do that. So I'm just going to say x equals 0. Okay, so now if we keep looking at step 4, it says slap this number on the number line with the 0 above it. Pick a number before and after to plug into the second derivative, and then plug those into the derivative. Okay, well, here's my number line with the 0 above it. And we're going to pick a number to the left and the right. And then we're going to plug it into the derivative, the second derivative, because that's where I got this 0 from. So now I'm going to plug negative 1 into this 40 over 9 times negative 1 to the negative 1/3. And all I want to know is if that's positive or negative. That's all I really care about. And I got a negative 4.4-ish. But who cares about the 4.4-ish? What I care about is the negative. So I got a negative and that means I'm going to draw a down arrow. Okay, on the next sucker, if I have an up arrow, that means 0 is an inflection point. If I have another down arrow, then 0 is not an inflection point. So let's put a 1 in. And when I type that in, I get regular 4.444, like a positive. So we go up. So inflection points only happen on our number line when we have a down up or an up down. Either way, the arrows have to be different directions. So I have one right here. So that means since I have a down and an up, my inflection point is at 0. This is good. My inflection point is at 0. But we just don't know the Y value. So I know my X value of the inflection point is 0, but I don't know my Y value. Okay, well, to find the Y value, under inflection points, it says to get the Y value of the inflection point, plug the number from the number line, that's 0, into the original function you started with. Okay, so I'm going to take this 0 and plug it into the original equation so that I can get my Y value. And when I plug in this 0 into the original equation, I think I just get 7. Yeah. So my inflection point is at 0 that we got from solving for X, and then 7 that we got from plugging back into the original. Okay, let's do this next sucker. This one says pretty much the same thing, only it wants concavity first. So we're going to do the same thing we did on this last problem, only instead of my first answer being the inflection point, it's going to be talking about these arrows. Okay, so let's go. For concavity or inflection points, we have to find the first derivative. So let's go. First derivative. Bring down the exponent. 6x to the subtract 1, 5, plus, bring down your exponent and multiply. 8x subtract 1. Now we have to find the second derivative, because concavity is about the second derivative. Bring down the exponent and multiply. 30x to the subtract 1, 4, plus just 8, because 8x just goes to 8. Okay, now we need to find the concavity, but to do that, we have to figure out what x equals. So I'm going to take this 30x to the 4 plus 8, and I'm going to equal it to 0. And then this is not like the last problem. On the last problem, we said if you have a number, then an x, then a number in the air, and it's equal to 0, then it plops out x equals 0. That's not the same as what we have down here. Down here, we have a number x to the number with something being added. So this is not going to plop out a 0. It's only if that 8 was missing. X would be equal to 0 eventually. Okay, for us, we're going to have to do old school math. Let's SAD math. To get rid of this addition, we're going to subtract 8. And we get 30x to the 4 equals negative 8. Then we're going to divide by 30. We're just doing a regular old SAD map. And I think when you divide this sucker and press math enter, enter, you get negative 4 over 15. Awkward. Okay, but then to get rid of an exponent, you put a house on top. Yeah, so to get rid of this 4 in the air, I'm going to put a house on top. But the only thing is that house that I put on top has to have a tiny 4 in the crook. So to get rid of an x to the 4, you put a 4 in the little crook. If we had an x to the 3, I'd put a 3 in the little crook. Okay, so let's see here on the left, all that cancels because that's the whole point of the house, is to make the exponent go away. So we just have x equals the 4th root of negative 4 over 15. What? But let's see what our tricks say for concavity. It says something about this. we're looking at the part that says, if you take the even root of a negative number, as in if the number in the crook is even and the number under the house is negative, then X has no solution. So I took an even power, or an even root, that's that 4, of a negative number. So that means no solution. Well, what the poop? The number I got from this was going to go on my number line, and it was going to tell me my concavity. But I didn't get X equals, so that means I can't put a number on my number line. Darn. Okay, well, let's see what happens when that happens. It says, when that happens, you cannot do steps 4, 5, 6. Instead, do this. Plug the original equation into y equals and graph it. Okay. So we're plugging the original x to the 6 plus 4x squared, and then we're graphing it. So I'm going to go to y equals and type in the original x to the 6 plus 4x squared. Then go to graph. Okay, and let's see what it's asking for. It says graph, zoom fit or zoom out to find your curve, decide whether it is concave up or down and over what intervals of x. If this happens, there is no inflection point. Okay, so we definitely have no inflection point. Now we have to figure out whether it's concave up or down. Okay, well, it looks like my graph is just a little bitty baby parabola. Let's maybe zoom out to make sure. I'm just gonna press zoom right here, then go down to 3, and then press enter. And as long as I still have a little, yep, baby parabola, yep, okay. So this is what our graph looks like, this weird baby parabola. Okay, let me take it back to normal. Zoom standard, number 6. So our picture looks like this. And we have to figure out what's concave up and what's concave down. So to do that, we can look at the front of our tricks, and it'll help us with the shape. If we look for something that looks like a little parabola, it looks like this sucker that says concave up, just a little parabola. Or look at this concave up, a little parabola. Or this concave up, a little parabola. So this whole parabola is concave up. It's concave up everywhere. Because the left side of this parabola looks like the left side of this concave up. Or you can say the left side of this parabola looks like this piece of the concave up. And then the right side of the parabola looks like this piece of the concave up. So it's concave up. And it's concave up everywhere. So part A and B said it's concave up, concave down. Well, part A is it's concave up everywhere from negative infinity to positive infinity. Part B, it says, where is it concave down? It's not. Because if I had concave down, my picture would look like a piece of this. And it doesn't. Okay, then part C said, what's your inflection point? Well, there is none, because I couldn't get one from x equals this because I took the even root of a negative number. So on this sucker, all we could answer was part A, the concave up. That was awkward. That was 2 kind of awkward ones in a row. Okay, let's do another one. Uh-oh. Okay, these are sign charts, and it says, draw f of x if this is our original t-chart, this is the sign chart for the first derivative, and this is the sign chart for the second derivative. Okay, well, first, let's go ahead and draw all these dots on a graph. At least we can do that. So let's draw a big graph. And we're going to draw negative 7.90. So that's left, negative 7.9, and then no up, down. Then we have negative 5, 6 up. Then we have negative 2.5, 3.7 up. Then we have 0, 0. Then 5, negative 2.7. And 7.9, negative 3.8. Did I miss one? No, I think I got it. Okay, so all I did was draw the points from this T-chart. Now we're going to look at this first derivative. Okay, if we look at this first derivative, the first derivative tells us whether we're increasing or decreasing. So this positive over here on the left means that we're increasing all the way from the left up to negative 5. So I think negative 5 was right here. So we're increasing, we're going up. Then from negative 5 to 5, it's negative. So we're going down, it's decreasing. So that means from this x value of negative 5 to this x value of 5, my line is going down somehow. Okay. Then from 5 all the way to the right, it's negative again, going down. Well, that makes sense because the only place we can go from that point that has an x value of 5, point that has an x value of 5, the only place we can go is down. So I need to pick the answer choice that looks like up, down, something like that. But that's not that great. I think you still have two answer choices that could be this. So that's when we look at our second derivative. Our second derivative, first we see it's negative, so that means concave down, and it's all the way up till negative 2.5. So I think negative 2.5 was right here. Okay, so that means when I connect the dots all the way from the left up to that one of negative 2.5, it's going to be concave down. So if we look at our pictures, concave down looks like this sucker. It's a parabola. Yeah, okay. So that means this piece of the curve is rounded. Yeah, rounded up. Yeah, okay. Then if we look, it says from negative 2.5 to 5, it's concave up because of the positive. So let's see what concave up looks like. Concave up looks like a parabola where we bow it out. Okay, so that means from negative 2.5 all the way to 5, we're concave up. As in, the piece of the curve that I draw needs to look like this concave up. And since we're decreasing in that area, decreasing concave up, it should be kind of bowed out like this. Okay, then the last sucker says from 5 to infinity, or 5 to the right, we have negative again. So it's concave down. And remember, concave down looks like a parabola, upside down parabola. So to draw from this point at 5 to the right, I have to draw a parabola, like the top of a parabola. So this left and right are bowed up. They make upside down parabolas. And these middle two suckers look like they make regular parabolas. Okay, let's do another one. First, we're going to draw these points. We have negative 1, 4, 0, 0, 2, 2, 3, 1, 6, -2, and 7, 0. Okay, I don't think you can see that very well. Let me maybe draw it again. Bigger this time. -1, 4, 0, 0, 2, 2, 3, 1, 6, -2, 7, 0. Okay. We'll use this bigger one. Okay, so first we're going to figure out kind of the general shape. So that's the first derivative. The first derivative says we are positive, so that means we're going up wherever the positives are and down wherever the negatives are. So this means from 6 all the way to the right, my graph is supposed to be going up. So from 6, -2, which is right here, all the way to the right, I'm supposed to go up. Okay, good. Then it says from the x value of 2 to 6, I'm supposed to go down. So 2 to 6 is from here to here, so we're going to go down. Then it says over here, all the way up until 0, we draw an up arrow. So all the way up to 0, we draw an up arrow. I think I wrote this wrong. This is supposed to be a -4. So this point is supposed to be way down here. So we draw an up arrow. Hey. I'm going to stop.